No Chance for Chance, written by me, Mike Labossiere, originally appearing in the Philosopher's Magazine, and then published in my book, What Don't You Know? Now, when it comes to chance, almost everyone believes in random chance. But my claim is that this belief is not justified. And to make this case, I'll draw an analogy to David Hume's discussion of causation. So, how does Hume's causation argument go? Well, it works like this. Most people, as I noted before, believe in causation. If we see a billiard ball striking and apparently moving another ball, we think we witnessed causation. But Hume claims we don't actually observe causation. We don't see the power. We don't see the necessary connection. What we see is just event X followed by event Y. We see the stick hit the ball moves. So according to Hume, if we observe enough instances of X following Y, we begin to expect that X will always follow Y. So when we see the stick strike the ball and it moves, and then we see it again and again and again, we expect that's how it works. So Hume also contends that regardless of the number of observations we make, we're not justified in our belief, because we don't actually ever see the causal power. So when we say that X causes Y, we're reporting a psychological claim that we expect Y when we observe X, that when we see the stick strike the ball, we expect that it will move. And so that's a short, condensed version of Hume's view of causation. But the whole point of this, of course, is talking about random chance. So when it comes to chance, as I noted before, most people tend to believe in chance. If you ask people like about dice, they'll talk about them, they roll random numbers. And also when it comes to things like, good luck and bad luck, etc., people tend to think there's chance. Things happen randomly. However, stealing from David Hume, my claim is that, of course, we don't see chance. In the case of the dice, we just see a die roll and land. In the case of other seemingly random things, we just see things occur, and that's it. We never see the chance. So then, why do we believe in chance? And these will be reasons in the sense of not, these are good logical reasons why it's true, but essentially an explanation. And so, like Hume here, I'm doing more psychology. Why is it that we believe this? The first is, we tend to attribute chance to matters that are unpredictable. In the case of the rolling dice, unless they're loaded, we can't predict the outcome typically. So if you are rolling a 20-sided die, it's going to roll some number between 1 and 20, but you don't know what the number is going to be. And you can work out, probabilities, etc., but you don't know the outcome. And because we can't predict this, we come to believe that chance must be involved. So the explanation is, gosh, I can't predict what's going to roll on this 20-sided die, therefore it has to be chance. Chance must be involved. Now, this does explain the psychology of the belief. However, there are many things that do seem unpredictable that we don't think are matters of just random chance. Like, chemical mixing, we may not be able to predict what's going to happen, but we need not think that it's going to be pure chance. So, unpredictability in any case is not the same thing as being random, because something can be perfectly determined, but we simply may be unable to predict this. So, saying something is unpredictable simply reports our ignorance, namely that we cannot predict it. It doesn't reveal the nature of chance. So, unpredictable, not the same as chance. Now, truly random chance, you might say, would be unpredictable, because if it's truly random, you can't say what's going to occur. But unpredictable is essentially our inability to predict. So unpredictability doesn't equal chance. Now, the second reason. We tend to think that something is a matter of chance if things could have turned out differently. As another example involving dice, think of dice. Suppose one is, playing a dice game at Las Vegas and rolls and loses. Now, we think that it could have gone differently. We could have won all that sweet, sweet Las Vegas money. So that seems to be perhaps a critical part of chance, that the result did occur, but it could have been different. Now we come to believe that things could have been different, and so we believe that chance was involved. Like in the case of, again, the dice, in the case of, games like football, if there's a pass and, the ball kind of slips around and then falls, we think, oh, they could have caught it if only things had been different. And we think there was like random chance there. And similarly, for any other event occurs, we tend to think that if things could have been otherwise, perhaps chance was a factor. But of course, chance is more than the possibility that things could have been different, because things could turn out differently in non-chance situations. So, take an example of someone making a decision. If a person has, free will, this would be a case where we don't want to say free will is a matter of chance, but by definition, free will is supposed to be such that you could have done differently. You could have made a different decision, but we wouldn't say that would necessarily be random. So we need something more than just unpredictability and thinking things could have been different. So what is this something more? Well, one possible something more is this. Things could have been different, even if everything was identical to the original event. Using, of course, yet another dice example, that we would be able to perfectly recreate the roll of that die. We could make like a precision dice rolling robot. We could, to ensure that the airflow is not a factor, we could have it, the dice roll like in a sealed vacuum container. And we could try to control for every factor we could think of. Now, there's an obvious flaw here. Namely, we cannot perfectly recreate the events. So, in the dice example, there would be factors changed from the original. Now, obviously, in cases if we're just, throwing a die down on the table, we're not going to be able to perfectly replicate like the exact precise hand movements. But what if we could, go to that kind of extreme example where you have like a dice rolling robot rolling dice in a sealed, vacuum container. So one might think that if you had unlimited money to spend and unlimited time, you could recreate the conditions perfectly by, again, my silly example, dice rolling robot, sealed vacuum container to take away airflow, dampening against the effects of gravity, the movement of the earth, just every single factor you could factor in. However, there'd be one factor that no matter what, you could never duplicate, and that is, of course, time. Even if you were somehow able to replicate every other single factor, time would remain different. And this is obvious because recreating is a recreation. It doesn't show things could have been different. Rather, it shows that the second or third or fourth time you did it, that perhaps things the second or third time were different than the first time. But that's rather and very much different from saying that things could have been different the first time. So using the dice example, this just shows that the result was what it was, and then the second result was what it was. We can't say that things could have been different. All we can say is things were what they were, and the second time they are what they are then, and the third time they are what they are then. But perhaps science fiction can save us here. So let us imagine time travel. So imagine you have a time machine, and this picture here is from the classic movie The Time Machine, based on the H.G. Wells book. They remade it, and the remake was disappointing. The original is an old movie, but pretty good. If you enjoy older movies, pretty good. So imagine we have our handy time machine here, and we travel back in time to witness the event again. So you set it up, you build your time machine, and you have somebody, they roll a die on the table, and then you take note of the result, and then you throw the lever, and then go back in time to see them, rolling it. So if things turn out differently when you go back in time, perhaps evidence of chance has been found. Now, if you go back and the same thing, happens, maybe there's evidence of a lack of chance. But then again, maybe not, because if you go back in time, one would think the same result. But suppose it's different. The first time, although talking about first times and second times is hard in time travel, but say as you're waiting there watching the die roll, it rolls a 12 on a 20-sided die. And then you throw the lever and go back in time, and then you see the roll, and this time it's like 8. And you may think, aha, finally, proof of randomness. It was different when I went back in time. But conditions are not exactly the same. And the reason is, of course, you travel back in time. So perhaps what changed the outcome was not chance, but your presence in the past when you went back in time. So when you appear, back in time, and now there's 2 of you in the room and 2 time machines, maybe it kind of startles your friend and the die rolls differently this time. So the time travel thing doesn't serve to show conclusively that there's chance, because the time travel may be what affected the change. Now, another option is, of course, parallel worlds, other realities. So a person might argue, and this is getting pretty extreme to try to just prove chance, is that to prove that chance is real, we would need a parallel world just like ours, in which, to use my dice example, the die came up some number other than whatever was rolled in our world. So imagine, like right now, we're standing at a portal to another reality, and the worlds are exactly alike, and I roll my die, and the Mike in the other world rolls his die, and they roll differently, and then we say, aha, there is chance. This proved it. Now, of course, this wouldn't help, because the die roll in the parallel world would not be identical to the die roll in our world. For the rolls to be identical, the worlds would have to be identical. That's to say, we would need to have just one world, not 2. So the parallel worlds, as cool as they are, do not solve the problem. So what is the conclusion here? Well, the conclusion is that our belief in chance, just like our belief in causation, as Hume argued, is based in our psychology and not on any firm foundation. We do believe in chance, but we have nothing to prove that chance is a thing. So stay safe, and I'll see you in the future.